This is my new motor drive on my Pfaff 230, and now I shall show you how it moves, and then I'll go into technical details afterwards. I start with a low speed. And then I go slowly up to max speed. Max speed. Here you can hear the sound of the tooth of the timing belt. So it might be a little annoying. And now I go up to max speed. This is max speed. The max speed is about 1780 RPM on the main shaft here. Now I will try to hold the shaft and start to. And you can see now the belt is slipping on the pulley here. So it's not able to cope with max torque. I measured this and it is about half the torque I like to have. I like to have a 3.5 Newton meter here. It is the same as about 250 Newton on a needle, or about 25 kilograms pressure on the needle. And it's needed for very heavy stuff. But if you don't need that, then this should be sufficient. I'll now try to put on some resin here to see if that could help. Otherwise, you should have a pulley here with some tooth in it. If you got a 3D printer, it's easy to make this way. Now I put a bit on this stuff on, and it is a recipe for belt wax. It was used in the old days for flat belts on machinery. I think I put about 50 cubic millimeters of this, and now it's like sticky on the surface here. So we'll try that and see how it goes. Now I put on the belt, and it is so that maybe it can slip just a little, but it is nothing like before. It do provide the full torque now. And so this stuff did help a lot. But it could also, when I feel here, I can feel that it has got a little sticky here as well. There will be some more losses at high speed, I think. So I'll try to measure the high speed now and see if it has influenced that. Actually, it's almost nothing. I measured it to 1780 before, and now I got 1775. So it's almost nothing changed here. So this can be a way, I think, to solve this slip problem. The motor used here is this kind of motor. It's a 895 motor, and it got 20,000 RPM at 24 volt DC. It's a quite cheap motor, and it is produced in very large numbers for battery power tools and something like that. The belt here is a timing belt type HTD 3M, and it is also produced in large numbers, and so is the pulleys. And this kind of belt is suited quite well for sewing machines, and especially the stronger household sewing machines. It's a 10 mm wide belt here, and this pulley is with 16 tooth, and this pulley got 155 millimeters in diameter, and it makes a transfer ratio about 10.5. I think I would go a little lower if I should choose today. Maybe I would choose 1 to 9 instead. I got a link in the video about the design factors for these pulleys and belts. You should look there, know more about that. This pulley is made of 9 mm finished plywood, and on the back here there is a 12 mm plywood. So it's a sandwich of two, and it is mounted with these 3 screws that goes into a threading made in the original flywheel. These are M4 bolts. What you see here is also a 9 mm finished plywood. On the back here you see a 6.5 mm finished plywood that holds the motor. And the motor, you can see that here, got 2 holes with M5 for M5 screws and 2 holes for M4 screws. And furthermore, it got some air holes here for sucking in air for the ventilator that is there. And in order not to block this air, I made 2 holes there so it can supply the motor with cooling air this way. And the 2 plates are held together with these 4 screws there. I also put on a little bracket there that goes against the body of the sewing machine. The screw is tightened in order to hold the motor like this.